Having estimated the conventional demand function, like we have it here, the next point is now to proceed with the transformation of this demand function into the inverse demand function, wherein price is going to be expressed as a function of quantity demand instead of quantity demand being expressed as a function of price. However, before we proceed into the transformation, a point needs to be made about the nature of the demand schedule from where we have derived both the slope and the intercept coefficients. The point that need to be made is that the demand schedule that we have just worked upon from where we derive the slope and intercept coefficient is the kind of demand schedule that is being regarded as a linear demand schedule. And why do we refer to this kind of demand schedule as a linear demand schedule? We refer to it as a linear demand schedule because a given change in price of this commodity brings about constant change in quantity demand of that commodity. Hence, as you can see, a change in price from 100 naira per apple to 150 naira per apple, which is an increase in price by 50 naira, brought about a decrease in quantity demanded from 60 units of apple to 40 units of apple, which is a minus 20 change in quantity demand. A further change in price from 150 to 200 naira per apple, which is equally 50 naira increase in price of apple, equally brought about a change in quantity demand from 40 units of apple to 20 units of apple, which equally represents a minus 20 change in quantity demanded. And the further increase from 200 to 250 naira per apple, which is equally a 50 naira increase in the price of apple, brought about a reduction in quantity demand from 20 to 0, which is equally a minus 20 unit change in the demand for apple. The scenario would have been entirely different had we been given a demand schedule wherein a given change in price of apple brought about irregular changes in quantity demanded. For instance, assuming we had a scenario whereby when the price of apple was 100, quantity demand of apple was 60. But when the price of apple increased from 100 naira per apple to 150 naira per apple, quantity demanded was 45. And when the price of apple increased from 150 to 200 naira per apple, which is equally a 50 naira increase, quantity demanded decreased to 40 units of apple. And when the price of apple increased from 200 naira per apple to 250 naira per apple, quantity demanded decreased to 10 units of apple. If we had a scenario like that, you would notice that an increase in price at this first point from 100 naira to 150 naira brought about a decrease in quantity from 60 to 45, which is a minus 15 unit decrease. While an increase in price from 150 naira to 200 naira, which is equally a 50 naira increase, brought about a decrease in quantity from 45 units of apple to 40 units of apple, which is a minus 5 unit decrease. And a further increase in price from 200 to 250, which is equally a 50 naira increase, brought about a decrease in quantity of apple demanded from 40 to 10, which is a minus 30 unit decrease. If we had a scenario like this, it would not be easy for us to utilize the equation of a straight line in order to estimate the demand function. So today we are focusing on derivation of a linear demand function, and we derive this linear demand function from a linear demand schedule. Having obtained a linear demand function from the hypothetical demand schedule given above, the next thing for us to do is to attempt a transformation of this demand function into inverse demand function. And like I've said earlier, the inverse demand function is a demand function whereby price is being expressed as a function of quantity demand and not the other way around. Ordinarily, if we were to draw a demand curve to represent the demand schedule that we have above, we are going to have a demand curve where quantity demand is going to be on the dependent axis while price is going to be on the independent axis. So we are supposed to have a demand curve where we have quantity demanded and price on this axis. But as you can see, when we drew the demand curve in our previous videos, we did not place quantity demand on the dependent axis. Rather, quantity demand was placed on the independent axis, while price was placed on the dependent axis. And the reason is because of the existence of inverse demand function. Hence, to turn the demand function into inverse demand function, the first thing we need to do is to turn the equations around by taking the terms in the right hand side into the left hand side and taking the one in the left hand side into the right hand side. So we have that 100 minus 0.4 P equals Q. Making P the summation formula, we're going to have minus 0.4 P equals to, this one is going this way, equals minus 100 plus Q. So for us to make P the summation formula, we're going to have P equals minus 100 divided by minus 0.4 plus Q all over minus 0.4. Hence, P equals minus 100 divided by minus 0.4, which is 250, plus minus 1 over 0.4 Q. So P equals 250 plus minus 1 over 0.4 is going to give us 2.5 Q. So we now have a demand function where price equals to 250 minus 2.5 Q, and this is the inverse demand function.